Hello everybody, welcome back to another video. In this video, we're going to be taking a look at a question from the IB Chemistry Paper 1 HL from the May 2019 batch, and this is from time zone 2. Now, this question asks us, which compound contains sulfur with an oxidation state of +6? Now, what exactly is this and what is oxidation state? Well, oxidation state, OS, this is oxidation state, describes in very simple terms how many electrons have been lost or gained by an atom. So this is the basic definition of oxidation state. It tells us how many electrons have been lost or gained by an atom in a compound or a molecule. That is what oxidation state describes. So for supposing for an ionic compound like NaCl, the oxidation state of chlorine is -1 and the oxidation state of sodium is +1 because sodium has lost 1 electron and chlorine has gained 1 electron, right? So remember, the gain of electrons is negative because electrons bring negative charges. And since sodium has lost one of its electrons, now it has one extra positive charge, or it has one proton, or the number of protons exceeds the number of electrons in the sodium atom now because it has lost one of its electrons. So it's +1. So in an ionic substance or in an ionic compound, it's pretty simple to determine what the oxidation state is, right? Because, well, something is losing an electron and something is gaining an electron. But what about in covalent compounds like SO2 or H2S or H2SO3? These are all covalent compounds. And you know that in covalent compounds, electrons aren't really lost by any atom. They are shared, right? We spoke about this in the Lewis structures and in many of my previous videos that in covalent compounds, we don't lose electrons like we do in ionic compounds, because in ionic compounds, there is a clear give and take of electrons, right? So Na gives the electron and chlorine receives the electron. But in this case, there isn't really any giving or taking, it's sharing, right? Because if we look at SO2, sulfur is bonded to two oxygen, is double bonded to two oxygens, and these electrons over here in these bonds are being shared. So there is no give and take. But how do we then assign oxidation states? Because after all, oxidation states talk about the oxidation state talks about how many electrons have been lost or how many electrons have been gained. And if in covalent compounds electrons aren't lost or gained, how do we give them an oxidation state? Well, let me tell you how and why we do it. The oxidation number for covalent compounds is just a concept, right? It assumes, we take that all compounds are ionic. We assume firstly that the compound is ionic, right? And then we assign the charges. So what I basically mean by that is that even though electrons are not being lost or gained, we just for the sake of simplicity and for the sake of understanding, we assume that the compound is ionic and then we assign the oxidation states, right? And what is the benefit of this? Well, it provides us with a guide to the distribution of electrons and relative charges on atoms in covalent compounds, right? And it allows us to understand redox processes more easily. What is redox? Well, if you don't know, redox is just a word combined with reduction and oxidation. And as you may know, reduction is the gain of electrons, is the gain of electrons, and oxidation, as I mentioned below, is the loss of electrons. An oxidation state looks at how many electrons have been lost or gained by an atom in a molecule. And in order to calculate the oxidation state in any molecule, whether it is covalent or ionic, we assume that the molecule is ionic. So we assume that SO2 is ionic, even though it's not, we assume it's ionic. We assume this is ionic, we assume this is ionic, we assume this is ionic. This is just for the sake of simplicity, right? Now, what is the rule to write or to figure out what the oxidation state is? The very first thing that you need to do, as I mentioned before, is to treat the compound as if it's an ionic substance. And if the compound is ionic, then the charges on the ions are the oxidation numbers. So we assume that this isn't that oxygen is an ion, and we assume that sulfur is an ion, and then we can assign them their oxidation states. So in the case of SO2, we know that in an ionic substance, something gains an electron and something loses an electron, right? We saw this over here. So how do we transfer this over to an covalent substance in where there is no gain or loss of electron, right? How do we do that? Well, we assume that the substance or the atom that is gaining electron or which is gaining the electron is the substance which has the highest electronegativity. That's what we assume. And in this case, right, you don't have your data booklet to check the electronegativity table. So how do you remember which atom or which substance to assign our negative values to? How do we do that? Well, it's a very simple trick. All you have to do is just remember FON. What is this? Well, sorry, we can do Cl and N. So these are the top four most common and most reoccurring atoms, which also happen to be the most electronegative atoms in the periodic table. So fluorine is the most electronegative atom, then it's followed by oxygen, and after that I believe it's chlorine, and then it's nitrogen. I'm not entirely sure about the last two. Please feel free to check that out by yourself, but I'm 100% sure that fluorine is the most electronegative, and it is followed by oxygen as being the next most electronegative atom. So in all these cases, in all of these covalent molecules, oxygen, right over here, this oxygen is going to be assigned the negative number or the negative value. So basically, oxygen is going to be the one receiving the electrons. It's going to be the one on the receiving end. It's going to be the one which has a negative charge on it. So in example, for SO2, right? One oxygen needs two electrons because oxygen is in group 16. And in order to achieve a full valence shell, it needs two additional electrons, right? So one oxygen atom would have an oxidation state of -2, correct? Like chlorine has an oxidation state of -1, oxygen has an oxidation state of -2. And since there are two oxygen molecules or atoms, we multiply this by 2. So basically, the oxidation number for O2 in this case is -4. And automatically, if you are giving something, or if these two different oxygen molecules need something, if they need 2 electrons each, sulfur must be able to supply those 2 electrons. So we give sulfur the oxidation number as +4. Just like we saw in NaCl. NaCl was -1, and sorry, Cl was -1 and Na was +1. And same likewise, we assume that SO2 is an ionic compound. We give oxygen the negative value because remember, it is more electronegative than sulfur, and thus it receives the negative value. And sulfur in exchange gets the plus value because it has to give the electrons. Now remember, in a covalent substance, there is no exchange of electrons. There's no giving and taking, there's only sharing. But we assign these values of +4 and -4 because it helps us understand redox processes much better. So this is purely conceptual and hypothetical, doesn't happen in real life, but is nonetheless a very important skill if you want to understand redox processes. Now they've asked us in the question, which compound contains sulfur with an oxidation state of +6? And clearly, as we did as we saw from this, by solving this, in this case, sulfur does not have an oxidation state of +6. It has an oxidation state of +4. So we can cancel this out. This is not the right answer. Let me just erase all of this. Now, what about the next part? What about B? H2S. Well, hydrogen is actually an exception to this rule about giving the most electronegative atom the negative charge. It is an exception because hydrogen can only afford to give one electron or to gain one electron. And its ability to only gain one electron doesn't make it a very good substance to act as the receiver in a covalent structure or in a covalent bond, because it can only receive a maximum of one electron, right? Otherwise, it'll fill up because that's its valency. So in every case, hydrogen always acts as the giver, not the receiver. So it will always be assigned the plus charge, if that makes sense. And in this case, sulfur has 6 electrons in its valence shell, right? Same as oxygen. It has 6 electrons and it needs 2 additional electrons to fill up its outer shell, right? It needs two extra electrons. So it's going to have a charge of -2 because that's its oxidation state. And hydrogen, on the other hand, each hydrogen can only have or only give one electron. So both hydrogens combined will have a combined oxidation state of +2, and each hydrogen is +1. So basically, it's +1 for each hydrogen, but since there are 2 hydrogens, we multiply it by 2. And clearly, as we can see, sulfur does not have an oxidation state of +6 in this either, so we can cross that out. Now let's take a look at the next part, H2SO3. Again, same concept. Oxygen is the most electronegative substance in this compound, so we assign it the negative charge. Since there are 3 oxygens, it will have a total combined oxidation state of -6, because remember, each oxygen has an oxidation state of -2. So times 3, that would give us -6. Now, we have hydrogen and sulfur. We know that hydrogen can only give a maximum of 1 electron each. And since we have 2 hydrogens, the combined oxidation state for this part over here will be +2. Now, as you can see, this molecule is neutral, right? There's no additional charge over here. You would know that some molecules like SO4 has a charge of 2- on top. Unlike that, over here, there are no charges, right? There is no charge. So that means that there's basically a 0 up here. So how is it a neutral molecule? Well, it's a neutral molecule because the positive charges that is supplied by H2 and S cancel out the negative charge of oxygen, negative oxidation state of oxygen. So in order to calculate how much sulfur or what the oxidation state of sulfur is going to be, you can do a very simple thing, +2 plus X, which is the oxidation state of sulfur, which we don't know, -6 is equal to 0, because the final charge on the molecule is 0, and we just solve for X. So X is equal to 4, equal to +4. And as we can see again, the oxidation state of sulfur is +4, which is not +6. So this is also out, and that leaves us only with one option, which is D, and D is also our correct option. I know that this is a bit hard concept to grasp and understand, but hopefully I've done a good job at explaining it. If you have any other questions regarding this concept or any other concept, please feel free to reach out to me on my social media or any other platform, and I will be more than happy to help you. Thank you so much for watching. I'll see you in another video with another question.